All right, algebraic reasoning. Today we're going to be talking about multiplying special cases. So there are special rules you can use to simplify the square of binomials and the difference of squares. All right, so we're going to first talk about the square of binomials. And what the square of binomials is about is if you have a binomial represented by a plus b, but examples like x plus 4, and you square it, there is a sort of pattern that emerges that will consistently emerge. So first off, let's talk about what does x plus 4 quantity squared mean? And x plus 4 quantity squared means x plus 4 times x plus 4. And so last time we learned several different techniques for attacking x plus 4 times x plus 4. The popular one is foiling, so we would multiply essentially every term by every term. So we would go x times x, which is x squared, and then we do x times 4, which is 4x, then we do 4 times x, which is another 4x, and we conclude with 4 times 4, which is 16. And then what we notice consistently happens every time we do this is the middle terms go together, and we get 8x. So we're left with x squared plus 8x plus 16, and we can't put these together because the rest of these terms are not like terms. Boom, there's our answer. So if we see something like, for example, the next one, x minus 3 quantity squared, we know that means x minus 3 times x minus 3, and we repeat the same process. So x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. And what we see once more is the middles match up, and we get negative 6x, and the rest is the same. So, well, let me do this. Plus negative and minus mean the same thing, or produce the same result. So we'll leave it as this. What I want to stress here is the pattern that emerges. And what we see in the middle here is that this is actually just what? Well, what are we actually doing? We're just doubling 4x here. We're just doubling negative 3x here. And that's exactly what always transpires. The middle term gets multiplied twice by itself. So formally speaking, if we look down here, when we have a plus b quantity squared, that is a plus b times a plus b. And so, again, if we just FOIL, you're going to and this is illustrated, you always are going to arrive at a squared plus ab plus another ab. Now, b times a is ab plus b squared. And since, again, the middles match up, it becomes 2ab. And because it's 2ab, that is just a fancy way of saying it's twice the product of a and b. Okay. Now you'll notice by a similar argument, a minus b quantity squared will produce the same result. In fact, all that goes on there is I would just change these to a negative sign, right? And all that would end up happening is instead of this being positive, this would become negative, and which then makes this negative 2ab, right? Because again, you're just adding, right, negative ab and negative ab, which gives me negative 2ab, right? What does this actually mean? What does this actually translate to? Why am I talking about this? Because if I give you examples like here, x plus 5 squared, I don't need to FOIL this. What we essentially did was we took the first value and we squared it. So we can take x and we squared it, right? Then you go to the back value, which is 4, and this is the first value. The second number, which is 4, or second value, which is 4, in this case it's 5, square it and put it at the back. The middle is the product, down here, right, is the product, this is what I was saying here, the product, right, of the two numbers, the two values in the binomial, multiplied by 2. That would be x times 5 times 2. So that's really just 5x times 2, which is 10x. And if you see that, you can, boom, jump straight to the answer, okay? So again, let's try this again. We're going to square the first one. So notice I get to square 3n, that's going to become 9n squared. We're going to square the back number, which is plus 1. Now, this is minus, so what we notice when it's minus, right, it does become, as we see here, instead of plus, it's going to be negative here. That's the only difference, so it's going to be negative. But it's the product of these two, 3n times 1, times 2. So that's 6n. And that's our answer. Okay, last one. So we're going to square 2x, which is 4x squared. We're going to square 9, which is 81. In the middle is the product of these times 2. So 2x times 9 is 18 times 2 is 36. And if you don't believe me, you're welcome to FOIL these out. Now, I mean, I will tell you, I very much remember my feelings towards this. When I was first exposed to this, I thought to myself, I don't need to memorize this. I don't need to do this. I can just FOIL. Well, the truth is if you're doing more advanced, more standardized tests, you want to be able to do this. And actually in future classes, you want to be able to attack these questions this way, because foiling is time consuming. And so if you have if you're doing like 10 of these problems and you're spending 5 minutes doing it, or I'm spending 1 minute doing it, that adds up over time. Okay. And these trends tend to help also on future problems, on more difficult problems. So these are ideas that are good to unpack in your head to use on future situations. Okay. All right. So there is another rule here, and this is the product of a sum and difference. And what this rule is, well, let's just do an example here. So if I give you x plus 9 times x minus 9, you're still going to FOIL this out. And this is going to, so if we FOIL this out, we're going to get x squared, right? X times x is x squared. Then we're going to do x times 9, which is 9x. And then we're going to do x times negative 9, which is negative 9x. And then 9 times x, which is 9x. And in the back, we have 9 times negative 9, which is 81. And so what I would do then is, again, the middle terms, because they're like terms, get put together. But what's interesting here is negative 9x plus 9x is 0. They subtract out. So this actually just leaves me with x squared minus 81. And this is a phenomenon that always occurs, because what's going to always happen is, and we can see an example here of this, right? You're always going to end up getting, if I FOIL this one out, it's going to become x squared plus 2x minus 4. The middle two terms always subtract out, because one is going to be negative and the other one's going to be positive. And so all you really have to do on a question like this, let's look at number 5 here. It looks more complicated, but it's really not. You just square both of them and put a subtraction sign between them. So 3x times 3x, or 3x squared, is going to give me 9x squared. Notice you do have to square the 3, and then square the back. So 4 squared is 16, so it's negative 16. Okay. And that's it. And even in number 6, that they're trying to scare you by having an x squared, you just do the same process. You square it. So what happens when you square, you get, we said that we multiply. Again, just to be clear here, x squared means I'm doing 2 times 2, which is 4. This is x to the 4th. And then I square the back. So what's 6 squared? 36. Put a minus sign between them. And that's it. And that is it. So again, to rehash, what we kind of went over today is, if you are multiplying a quantity squared, all you have to do is square the first term, square the back term, and then multiply these together times 2. So 4x times 2 is 8x. Okay. We'll do another example, x minus 4 squared. So again, square the first term, square the back term. Oops. Trying to be consistent here. 16. And then multiply 4 and x together times 2, which is 8x. Just remember, because now it's negative, this needs to be negative. Okay? And the other situation that we discussed is if we multiply two values where the signs change, then all you have to do is square both of these and put a minus sign between them. And that's it. So hopefully that makes sense, and I'll find you guys in the next math video.